Assalamu alaikum. I'm engineer Hamna Shakil. In this video, I will solve problem number 104 that is related to normal stresses from chapter number 1. The problem statement of problem number 104 is a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kN. Determine the outside diameter of the tube if the stress is limited to 120 megapascal. Let's understand the problem first. So they're talking about a hollow steel tube. Let's make a cross section of the hollow steel tube. The inside diameter of this tube is 100 millimeter. So the inside diameter is here. Let's denote it by small d. This hollow tube is made up of steel and it must carry a tensile load of 400 kilonewton. So tensile load means that you are stretching the pipe. You have to determine outside diameter of this tube. Let's denote the outside diameter by capital D if the stress is limited to 120 megapascal. So the stress is limited to 120 megapascal. This is the side view of the pipe. These dotted lines represent the hidden lines and this is representing a hollow tube. So you're applying a tensile load of 400 kilonewton, means that if you have a tube like this, you're applying a load of 400 kilonewton and you're trying to stretch it. So now we have understood the problem. Let's try solving it. Let's do it the conventional way. Start by writing the data that we know about the problem. So we know that the inside diameter of the tube is 100 millimeter. So small d is 100 millimeter. Tensile load is 400 kilonewton. So let's denote it by PT, tensile load, 400 kilonewtons, which becomes 400,000 newtons. The stress is limited to 120 megapascal. So it means that if you apply stress more than 120 megapascal on this tube will either break or it will fail. In other words, you can say that the capacity of this rod is 120 megapascal, right? So capacity of this rod is 120 megapascal. So this will become your tensile stress. Let's talk about this unit a little bit. Pascal is equal to Newton per meter square and mega is for 10 raised to power 6. So 120 megapascal can be written as 120 into 10 raised to power 6 Pascal or 120 into 10 raised to power 6 Newton per meter square. Also, 1 megapascal is equal to 1 Newton per millimeter square. So you can also write that stress is equal to 120 Newton per millimeter square. So here is all the data that is given in the problem. Let's start solving the problem. So what we need to find is outside diameter of the tube, capital D. For normal stresses, we know the formula is load divided by the area. So here the load is 400 kilonewton and it's a tensile load. And the cross-sectional area on which this tensile load is acting is the area of this hollow tube. So let's plug in the values here. We know the value of stress, that is 120 Newton per millimeter square. The value of load applied is 400,000 Newton. divided by area. We need to find the diameter, and we can find the diameter if we know the area of this tube. So it's a hollow circular steel tube, and we know that the area of a circle is pi by 4 into d square, where d is the diameter of the circle. So the area of the hollow steel tube becomes area of hollow steel tube, that will become pi by 4 d square, capital D, which is the outside diameter, minus pi by 4 into the inside diameter square. So this is the formula for the area of a hollow tube. Let's plug in this value in the equation and see what happens. After plugging in the equation of area in your main equation, this is what your main equation will look like. So we need to find the outside diameter, and we already know the value of inside diameter. So let's plug in all the values that we know. After plugging in the value of small diameter, let's rearrange the equation. So you have Newton in the numerator and you have Newton here in the denominator. They're going to cancel each other, and this millimeter square will go here on the numerator. Let's further rearrange this equation. So this equation will become further rearranging it, d will become plug in this equation in the calculator, and the value of capital D will come out to be 119.35 millimeter. So here is your answer. The outside diameter of the hollow tube shall be 119.35 millimeter on a condition that the stress is limited to 120 megapascals.